Hello, I'm Robert Wolff.
And I'm Gabriel Peterson.
And you're watching Innovation Coffee. Hello, everyone, and welcome to Innovation Coffee, brought to you by ARM, where the coffee is hot, the innovation is hotter. Let me take a sip here real quick. My name is Robert Wolff, and this is Gabriel Peterson. Do you want to say it?
I was going to say it.
Go ahead.
Well, now it's too late. You've already ruined it.
Yeah. We are your co-hosts this week and every week when we take a deeper look at ARM developer ecosystem, ARM the developer ecosystem, and explore the many things going on in and around this exciting space. Each of these live streams start with developer updates, followed by in-depth conversations with esteemed individuals and ARM experts, as well as partners from the developer ecosystem and community. We discuss a plethora of topics tailored for developers and showcase opportunities, as well as explore resources and bring new and exciting ARM developments to light. Each of these events usually finish with a Q&A, an audience Q&A, though if you have questions throughout the stream, feel free to toss them in that YouTube chat. And if you're watching this on demand, you can also throw them in the comments. We do monitor them the best as we can. And if you do have something that comes up, toss them in there. We'll try to get those answered. Now, as a reminder, if you enjoyed this live stream, don't forget to smash that like button and subscribe to the ARM Software Developers YouTube channel, where you can get access to all sorts of fun interactions like this one, live streams, various on-demand content, tutorials, workshops, etc., etc. So don't forget to subscribe. Now, Gabe, we have a pretty exciting episode today, right? And maybe some people have noticed our background, our new backdrop, and this little machine that we have kind of positioned here, and we'll talk about that in a minute. But Gabe, what do we have going on today?
Well, we have Dave Neary from Ampere, so he's going to be able to talk us through a little bit of the box we have behind us and a little bit of a teaser for what's to come next weekend.
That is open source.
Yes,
cool. So as Gabe just mentioned, we are joined today by Dave Neary, who is the Director of Developer Relations at Ampere Computing. Now, for those of you who are not familiar with Ampere Computing, that's okay. Dave Neary is going to fill us in on that. For those of you developers out there or who are looking for a new and exciting place to develop and build cool things on ARM, Ampere is the community, the developer community to be a part of, as well as, of course, the ARM developer community and the ARM developer program. But yes, we will talk about that, of course. Now, I think it's important that first, let's bring Michael in here, because Michael, our fellow developer evangelist and co-host. Mike, how's it going?
Hey guys, going well. I am jealous that I'm not there in the studio with you. That is looking sharp.
I know, right?
We have extra seats and extra microphones just for whenever you visit.
Yeah. I was like, forget that. Mike's never coming out here. And Gabe was like, no, we got to get him one just in case. So Mike, you were the one who I don't want to say bagged, but you were the one who came in clutch here with Dave Neary, because our guest this week canceled. Dave came in, last minute, and tell us a little bit about your relationship with Dave before we bring him in.
So Dave and I have known each other kind of off and on from the Linux community for years. We never were quite in the same project or the same company, I don't think, but we were always in each other's orbits. So we knew of each other. We would run across each other at conferences. And then, when I knew Aaron Williams, who was on a couple months ago, from my time at the Linux Foundation, and now he's at Ampere working with Dave. So I'm like, oh, these two guys, I know them both. I respect them both. Great opportunities there. So I reached out to him and asked if Dave could come on our show, and he graciously said yes. So I'm real excited.
Very cool. Yes. And I remember actually going to some of these Linux Foundation events or Cloud Native Compute Foundation events, KubeCon, for example, 2019, or ARM TechCon 2018. And the developers would just drool around the Ampere booth, because they were one of the first people putting out these chipsets, putting out these ARM-based compute platforms in the cloud, right? And so everyone was like, oh, I wish I could get access to one of those. I wish I could have one of those server racks in my home, right? Well, it's You don't need one in your home now because they're pretty much featured with all of the major cloud providers. And this is something that I'm very excited now to let Dave talk a little bit more about. Of course, we want to get to know him on a personal level first, but let's bring David onto the call. So Dave, hello.
How you doing?
Great. Thank you for joining us. How are you?
It's a pleasure to be here. I'm pretty good. Yeah, it's quite hot here. It got hot after we got rained out last weekend, so we had no barbecues over July 4th weekend.
Where are you based?
I'm in Greater Boston.
Oh, okay.
So,
I've been to Boston a few times. Very nice area.
Boston people don't call it Boston. That's why I say Greater Boston.
Gotcha. And you have your coffee with you?
I do have an empty coffee cup with me.
Oh, well, we'll still cheers your empty cup. There, cheers.
Cheers.
So, Dave, we want to know your origin story. Who are you? What do you do?
Well, as you can tell from the accent, I'm not originally American, right? I'm Irish. Discovered Linux in 96, 97 while I was still in college. And from about 99, 2000, I was a contributor to multiple open source projects. I was a developer on the GIMP for several years. That got me involved in the GNOME project, which is kind of where I came across Michael through. He was working for Canonical on Ubuntu. And so I've been around open source for 25 years ish. That makes me feel older than I feel.
Right. I try not to do that. Think about
it's terrible.
Well, 26 years, isn't that that's like 1 year after it was not open source in itself, but like when did the Linux kernel get created? Was it
94? I think the Linux kernel, I think.
91.
Oh, 91. I'm a little late on that. So you were a little late to the game.
By the time I got into it, I think it was 97. I'd been using Unix in college for some of my programming work that I needed to do. We had Unix workstations, Sun Solaris. And I remember one day it was a friend of mine who was a Linux fan said, you should just be, rather than having all these telnet windows up and I had, I think, the Hummingbird X server, and I was running Emacs Windows for anybody who wants to reminisce. And he said, you should just cut out the middleman and install Linux on your desktop, which is what I did with his help. So yeah, Red Hat Linux 5.1 was the very first distribution I used. So
back before it was Red Hat Enterprise, even.
That was that was 6 years before Red Hat Enterprise, or 5 years before Red Hat Enterprise Linux. So it was let's say early adopter, but not the very, very first days. It was already pretty user friendly by the time I got involved.
I think that's a great origin story. It lets us know kind of how you've been around the block, right? And so you're equipped here to answer questions for developers. You're equipped here to lead this developer community. And I think that's awesome. So,
someone in the chat was just asking, whereabouts in Ireland are you from?
Yeah, I grew up in Mayo, west of Ireland.
Mayo. All right, cool.
I'm gonna nod.
So is that why you landed in Boston, because it's the most Irish part of the U.S.?
There's an argument for that. No, actually, I moved to Boston with Red Hat. I was working for Red Hat for about 10 years before I joined Ampere, and joined them working remote with the open source program office there, and moved to Boston because they had a large office in Westford, Massachusetts. I'm living in Littleton, Massachusetts, next town over. So been here for 8 years now.
Oh, great. Cool. Well, so Dave, thank you for, letting us get to know you a little bit here, and for our audience as well. I think I'd like to dive into kind of the main segment here, the meat of this discussion. And this is talking about Ampere. Of course, Ampere, the company, and then Ampere, the developer community. So first off, for anyone watching this show right now, could you tell us at a very high level, what is Ampere computing?
So the highest possible level is Ampere is about 5 years old. We design CPUs. We design processors. Those processors contain ARM cores. And basically, the founders of the company were looking around the industry and saying, look, we've got this huge, massive new paradigm, which is cloud computing. And we're still catering to that industry, that new paradigm, with processors that are based on 30-year-old technology, the x86 platform. We need to innovate. We need to think about what are the requirements of cloud applications, what are the requirements of cloud application developers, and then deliver a platform that gives them those requirements. Some of those requirements are performance for sure, cost certainly, but also things like power and real estate. Right. What we've seen is as the cloud has increased, the power demands of the cloud have increased, the real estate demands of the cloud have increased, and the Ampere processors. Really, our goal was to deliver as much compute as possible without requiring additional cooling, power requirements, without requiring additional data centers.
Yes, this is a good point, right? Like, I mean, I guess when I think of ARM in a lot of ways, I think of cooling, I think of sustainability, I think of energy savings, but a lot of people I think have not really made that connection in that where is the loss? Is there a loss in performance? Is there a loss in XYZ because I'm saving all this energy? I'm saving all of this. I must be losing something. So
sure.
Could you tell us that we're not?
Well, I can tell you that ARM processors have been rapidly increasing the performance that they deliver, right? With basic general purpose compute. Now, I'm not talking about ARM-based GPUs or anything like that, we can get into that a little bit later, perhaps. But just for general purpose compute, the ARM cores are 3 gigahertz, which is about what's useful for cloud applications. We provide a large level 2 and level 1 cache per core, and a high-speed interconnect for memory. So basically, you're getting the same performance as you do with an x86 processor, just you're getting more cores per socket.
And this is how you end up with a situation where you have like a chip with 128 cores or 64 cores, and you're getting
up to 192 with Ampere 1, which we just recently announced.
Boom. There you go.
Nice.
Yeah. Very cool.
When does that come out? Like, when can we get our hands on that?
Well, yeah, we just got this yesterday, Gabe. Come on.
I honestly, I don't know. I have to admit, and we can talk about this a little bit later, but as kind of running the developer program, and I'm interested in hearing what you all think about this as well, is I'm more focused on what people can get their hands on today than what's coming out soon. So while I do stay in touch with what we're doing in like future roadmap plans, I know we've announced the product. I know we are very close to release, but I honestly couldn't tell you when you can get your hands on it.
Yeah, and it's funny because like for me in particular, and I'll just kind of move away from the chipsets and devices. I think, oh, well, should I buy the Oculus 2 or should I wait for the Oculus 3 to come out? And this goes in line with the X13S. I believe it is the Lenovo X13S that's now featuring the Qualcomm chipset, this laptop, right? Amazing laptop. All the kernel developers all the open source folks are working and using this laptop, but the next one is coming out. I'm like, do I buy the one that they're working on now, or do I wait for the next one to come out? You're always kind of trying to keep up with this tech, but I like your philosophy there. What's available now? What can I use now?
Because you had to kind of correct me on that yesterday when we were talking about what boards we wanted to bring to open source. And I'm like, well, that came out a couple of years ago. And you're like, people are still using it. It's still good. It's
yeah. And it always depends on the use case. So Mike, I could bogart this entire conversation. What would you like to ask a question here? Please interrupt, by the way.
One of the things, like, I've been a developer advocate for a long time, but it's always been about software. So when I came to ARM and I have to start thinking about developers in terms of hardware, like that was a mental shift that I'm having to make, and how I talk to people and what I talk to them about. So my question broadly is, what does developer relations mean for Ampere?
Well, that's a really great question. I think the very first starting point for something like that is, what do you mean by developer? Because developer is such an overloaded term, right? It can apply for everyone.
I love your return question.
Yeah, it's a meta question, right? So what do you mean by developer? Well, what we're thinking about as developer is not people who are working on firmware. It's not people who are working on operating systems. While those are very important for Ampere because those are things that people use, I'm thinking about people who are doing stuff on the top. So typically it's people who are getting instances of ARM VMs or containers running on one of our CSP customers. So that's when I'm thinking about a developer, that's what I'm thinking about. I'm thinking about the people who are designing cloud applications, the people who are doing all of the build CI/CD deployment pipelines for those applications. People who are operating them in production, and then data science. The people like those applications generate data. What happens with those data? With that data, how do you apply it later? So it's AI inference and workloads like that.
So you're thinking top level workloads, application engineers in a way.
Yeah,
that level. So
right.
you don't go. So you're not down on the low in like the slums working in the power management kernel. And
I would not be able to tell you the difference between x86 and ARM ISAs. I don't know that.
Yeah. No, that's cool.
Not the level I operate on.
And to be honest, I mean, you're tackling, I think, the broadest group of developers, right?
Absolutely.
I mean, like
as you go down pyramid, right? The lower you get in the stack, the fewer people there are who are experts at it. There are only so many people who can do, hardware description languages. Even there's a little bit more that work on kind of firmware and low level BIOS software. A little bit more working on operating system. But as you go further up the stack, you're getting more and more developers. There are way more JavaScript developers than there are hardware hackers.
Yeah, we have some comments here from Marchin. Developers as server users rather than software developers, and
Absolutely,
then more DevOps.
Exactly.
Yes, exactly.
Yeah.
Cool. Well, that's awesome. I kind of wanted to talk to you about this kind of, I guess it's a complementary question here. So we're talking about the Ampere. What does developer relations mean to Ampere? Let's talk a little bit more about the Ampere developer community. So where do these developers congregate? Does Ampere have any developer programs? Is there anything that Ampere is doing to enable these developers and facilitate the migration from x86 over to ARM?
Sure. Well, there are two main resources. We've got a developer center where we concentrate all of our benchmarking information and tracking which software works well and what versions you should use, and kind of tutorials on doing higher level tasks on Ampere. And that's developer.amperecomputing.com. And then we have an interactive community forum at community.amperecomputing.com, which is where we see people like Hurva, Marcin, turn up. And so that community brings together two groups: people who are enthusiastic about the ARM platform and people who are enthusiastic about cloud application development. As Marcin said, the DevOps world. So our goal is really to join those and make sure that if people are having any issues embracing the ARM platform for cloud use cases, that they have people that they can talk to.
So I just found the Ampere. Thank you, by the way, for those answers. I just found the Ampere developer area there. It's amperecomputing.com/developers. But you said another link there. I'd like to get that one added in.
Yeah, it's a redirect from developer.amperecomputing.com. It's exactly the same.
Oh, it'll just take you right to where we put there.
Exactly.
Oh, perfect. All right. So yeah, there you have it. Okay. So if you are entertaining developing on ARM on Ampere chips in the cloud, wherever you may be going, you can find a lot of resources at this area here in these websites. So you have,
and this is, one of the issues that we have. Every single CSP that deploys Ampere, and you can get Ampere processors. We're the ARM provider for Microsoft Azure, for Google Compute, for Oracle Cloud. Those are the big North American clouds that are our customers. But also in China, we have Tencent, Baidu, ByteDance, etc., Alibaba. So pretty much all of the large CSPs, except for Amazon, who are their own ARM provider, use Ampere hardware. And we also have multiple options for hosting, right? Bare metal hosting, Hetzner and Equinix are the two largest. But basically, if you want to use ARM in the cloud, you've got Graviton 2 at AWS, and you've got Ampere. So all of our developer collateral, because we have so many cloud customers, we try to be cloud agnostic. That was the point I was getting to in a roundabout way.
I like what Marcin put it here. He's like tutorials.
Yeah.
So yes, go get access to all the tutorials on amperecomputing.com/developers. So let's continue on with some questions. Go ahead, Gabe.
Yeah, so of course I've mentioned a couple times we're going to be at Open Sauce next weekend.
Yep.
It's showing off some various ARM technologies. And one of them we're bringing with us is, well, it's an exact copy of the box we have behind us, the developer platform. Now, being from Ampere and having a different company show off your hardware, what are you hoping will show off? Like, or what are you hoping that people will come to take away after viewing this in person? Because we will have it up and running. It's not just going to be like turned off and on display. It's actually going to be we're going to be showing it off.
Well, I mean, it's kind of hard, right? Like, how do you communicate the benefits of a hardware platform by saying all the stuff that you're used to using just works? Because that's kind of the table stakes of it all is, if you want to run a Linux distribution, if you want to run your Oracle database on it, you can do that because it just works, right? As we've seen the last 5 years, ARM has moved up into that data center category in a big way. We've seen the entire software ecosystem around cloud computing embrace it. I will say, I haven't actually seen an 80-link developer platform myself. I haven't had my hands on one. But one of the things that I've heard increasingly often from people is that they really appreciate having real server-grade ARM hardware available for CI/CD, build, testing, porting. That before, if you wanted to do CI/CD in the cloud, it's kind of hard. You're either cross-compiling or you're using VMs, and VM in VM doesn't work on ARM instances. Having real hardware gives you the flexibility to do real production level workloads in your lab.
So is that kind of the point that you're hoping will make to people who are looking at it, that it can just be done? Like, they don't have to make drastic changes or anything like that. They can just get one of these boxes essentially and start developing on it and porting over their existing code base.
Well, I mean, there's not a lot of porting to be done, frankly. A lot of this stuff just compiles straight out of the box. I will say one of the things that I'm hoping people appreciate is like the power of having 32 or 64 or 80 cores in a tower format, right? Yeah. That gives you a lot of compute performance. 3 gigahertz cores. Like, how big of a Kubernetes cluster can you run on that? It's a lot of muscle.
A lot.
So that's actually something that I've heard from developers talking about, like just the core density that you can get now with ARM is that when you're running microservices in the cloud, it used to be you got a virtual CPU, which meant you were sharing time on a single core with some other person and their services. But now with these, 192 core CPUs from Ampere, you can get dedicated, and I think this is what Oracle's doing. You get a dedicated core. Even at the lowest tiers, you get a full core all to yourself, and you're not having to share that.
Yeah,
so from my perspective,
it's one of the selling points of Ampere processors is that they're all single-threaded cores. So there isn't the concept of hyper-threading and sharing a core across two tenants doesn't exist, right? So you're getting a full 3 gigahertz core, which gives you performance linear scaling. Right? It means that when your application gets more load, it's going to perform as well until it hits the capacity of the chip. Whereas what you see with alternative platforms is when you get to about 40-50%, you start to drop off in performance. You tend to increase latency because there's more waiting. So you end up running with kind of multiples more cores, virtual CPUs, because you can only load them up to 50%.
Yeah. So as Marcin says in the comments, no multiprocessing means that you don't have a noisy neighbor problem there.
I mean, we still have potential noisy neighbors because you're sharing, a bus, you're sharing some interconnect on the mesh. But for the most part, that's absolutely right. When you get a core, you get a core.
I'm curious to kind of, I guess, understand a little bit more about how developers can get access to these devices, or I should say these chips in the cloud, and a little bit more about the benefits that Ampere is touting in terms of the transfer over, because I could speak on behalf of ARM and say, oh,
Right.
yeah, well, these are the benefits that ARM brings to the space, right? But so like, could we talk a little bit about the benefits or the messaging that Ampere uses for their developers in terms of why it's important for you to consider Ampere chips over the alternative, right? Because when you go to these cloud services, you go to AWS, Oracle, Google Cloud, all of these different services, you get hit with a lot of different options, from not only from compute power, but from storage options, et cetera, memory options. So maybe you could kind of like, if I'm a developer watching this right now and you get, some time to convince me to go give it a shot, go choose that Ampere based instance, what would you tell them?
Well, first you got to choose the right workload, right? And one of the great things that you have available to you now is if you're using something like Kubernetes for container workloads, it's pretty easy to do a heterogeneous Kubernetes cluster now. You can have a node pool that's running x86 and a node pool that's running ARM, and you can choose what pieces you use on which platforms. So the question is, what workloads work best on the ARM CPUs? In general, those are going to be CPU intensive workloads or workloads that use a lot of memory because like RAM access is slow, disk is slower, L1, L2 RAM is much faster. Right. And because we provide that large L1, L2, which is a private cache, and then you've got the RAM access being slower, but still a lot faster than disk, you can use high memory instances with the Ampere CPUs that will provide generally 10 to 15% performance improvement is what we've seen for memory intensive workloads. For compute intensive workloads, again, because we have linear scaling up to like 100% load. I'm exaggerating a little, but you can load Ampere CPUs up to 80% and you don't see any impact on latencies. Because of that, because of the ability to get cheaper cores, the reason why those cores are cheaper is because we provide more cores per socket. So even though the server is comparably priced or maybe a little bit more expensive than an x86, the cost per core to the CSP is a lot lower, and they pass that cost on to the customer. Also, lower operating cost because of electricity, cooling, etc. Again, provides an opportunity to pass that cost savings on.
And we're hoping that these cloud providers don't just increase their margins.
In general, they don't, and the reason why is because they all have the same hardware, and it's a competitive market. So you got to stay competitive. Somebody else can reduce their cost by 10%, and you got your cost 10% higher because you're maintaining an extra margin. That's a competitive disadvantage, right?
So what about, sorry, I'll let you guys hop in here. I know you guys have a bunch of questions.
I did want to finish a point, but
please.
So we've got the reduced cost, but also because you can load these cores up more, you tend to use for compute intensive workloads, fewer cores to do the same work. So you can get the same performance off, again, we're talking about microservice clustered applications. You get the same performance off fewer cores than you do on x86, which means you're saving doubly. Not only you're paying less per core, you're also using fewer of them. And we've seen up to 4x price performance benefits for certain workloads, like compute intensive Java workloads in microservice environments. So that's a pretty compelling argument.
So what about like in terms of multi-threading, right? So I mean, like when you're talking about having 100+ cores, right? If you wanted to like, spread your workload across all of these cores. Whereas when you look at like the x86, like you're not seeing as many cores on a chip. And so, I mean, is this something that can be touted as well, or is this just not really a thing?
Well, I'll say there are two ways to scale in the cloud. One is to have bigger instances. So you use more cores in a single VM, and then you rely on the software to distribute the workload across those cores. Or you can have smaller instances and have many more of them, and then you rely on something like a load balancer to distribute the load. In both cases, you can do that with Ampere. You can scale, you can get multiple cores on a single socket, so you can scale vertically or horizontally in your VMs. But I'm not sure I understood your question. Like you talked about threading.
Sorry, I guess maybe I'm asking it wrong. My point is more about it was about scaling. So it was about
Okay.
or executing on a workload, running a workload,
right.
and taking full advantage of the fact that you have all of these cores that are able to operate somewhat independently if you wanted them to. And so you could have this you could have 100 cores and you could have this workload that's just utilizing one of those cores, or I could have this workload spread across the 100 cores, utilizing a fraction of each core to make sure that this executes. It's kind of like thinking in terms of an FPGA, right? Like you could look at an FPGA and say like, oh, I want this DSP application to run across all these different filters going in, and you can have all of these different things running in parallel at the same time, right? So that's more so what I was thinking about in terms of,
and some of that is going to depend on the programmer, right? If you are running, let's say, a build process and you're only running your build process single threaded, or like you're running your builds in sequence, you're not going to be using any more than one core at 100%, right? You're just going to be kind of completely filling up one core, whereas you can run them in series and you can fill up your 92 cores or 128 cores or now 192 cores. So part of it is going to depend on good programming practices from the cloud developer to make sure that you're optimizing, that you're filling up your CPUs. But yeah, you can certainly, as I said, we afford you the opportunity to scale both horizontally and vertically.
Nice. Okay, I've taken enough of these questions. So yeah, Mike, maybe
I just want to bounce one thing off of what you were saying, Robert. So one thing that I like about Oracle's free offering on their Ampere nodes is that on the free tier you get 4 cores, and then you can decide if you want one VM with 4 cores available to the OS, or if you want 4 separate VMs, each with 1 core available. So like depending on what your workload is, you can change that configuration however you want.
There you go. Nice. Very nice. And those are Ampere in Oracle.
Yes, they are.
Yeah.
Yes.
Yeah,
Cool.
I should say the instance types, right? So on Oracle, we're the A1 instance. On GCP, we're the Tau T2A instance. And on Azure, we're the DPS series VMs. So DPS v5, DPS v5, and there's another one. I don't remember. All of the clouds have instance naming that's kind of weird, but
yeah. Go ahead, Mike. Sorry, I didn't mean to interrupt.
Yeah, Dave, you mentioned earlier Java developers and microservices, and that's one of the communities that I've seen a lot of interest and activity around ARM porting and ARM optimizations from.
Right.
I was wondering what other like languages or frameworks or tech communities do you see there being a lot of opportunity for ARM adoption, or maybe challenges to it?
Well, I would say like the challenge traditionally, I guess, is C, right? C computing is a little bit lower level, C and C++. But actually recently we have a French company called Amadeus, who's ported very successfully a C++ workload. And they did find some issues, as you would with compiler sets and runtimes and related to the architecture. But they've been able to port a large enterprise C++ application pretty simply. I would say all of the popular runtimes that you expect to see, Java, C#, JavaScript with Node.js, and Python, all work out of the box on ARM. And in fact, in recent years, a lot of, and Go, I forgot Go. And we've seen a lot of performance optimizations in the compilers and interpreters and the language runtimes. So for example, between Java 8 and Java 17, I saw one person on the Ampere community said it was like a 17% speed up on the same benchmark, which is huge, just by upgrading your JVM.
Yeah, I talked to several people who are working for companies that are optimizing the JVM and implementing ARM intrinsics in the JVM, just like they have the x86 ones.
Yeah, speaking of this, is that my hearing something?
Yeah, no, I'm hearing it too. Hopefully, you
if you're
can't
hearing
hear
a
it.
cat,
We're not
my
hearing it.
parents'
Just
cat.
to
Yeah,
let you know.
that's all right. There's some grinding or something happening either
Yeah.
above us or to the side of us. But yeah,
Right.
and
Somebody
which
left the copy grinder on.
yeah, maybe.
It kind of sounded like the coffee maker was going off on its own. That's
Yeah. But yeah, so gosh, now I'm gonna forget my question because it was important too. Darn it.
Well, I can.
Okay, yeah,
I
Phil,
have a
think about it.
question while you're remembering. So one of the things that's kind of cool that I've seen some videos on, also read some blogs on, is people taking the developer platform and installing Windows and running games on it. Now, I know obviously that's not its intended use case. It's just one of those things that people do that's cool to see. But as far as the Windows installation goes, is that something that Ampere has been supporting and encouraging, or is this just kind of enterprising developers going off on their own and doing it just because they can?
As a hardware vendor, our job stops at some point. And I'm happy for people to run whatever software they want on our platforms. And so yeah, when I see like Jeff Geerling had a video where he was
That's the same video I just saw.
He had trouble with so to go back to our Ampere Computing forum, community forum, Jeff came onto the forum and was sharing that he had some issues with the ARM build, and was able to connect with Alessandro Petroni and another developer from Cloudbase, which is a company that does a lot of free software work around Windows, and was able to get around those problems. So yeah, I love to see vendors that traditionally have not been ARM vendors embracing the ARM platform. I think it's a really good thing. And Oracle just announced their Oracle database is available for ARM, and that's going to be on Ampere hardware. Microsoft has Windows on ARM. Pretty much all of the major desktop operating systems now run on ARM.
Yeah, and for those of you who are itching to go look at the video we were just talking about, I did share it in the chat there. Also, for anyone watching on demand, you can check it out. It will be in the description of the video. So yeah, very interesting stuff. And Jeff Geerling, he's a great guy. I think he's in the ARM developer Discord server as well. We have him as one of our featured developers. Very cool. So let me see here. Let's go back to getting started for developers seeking to build on Ampere.
Right.
So on Ampere, I'm supposed to use the ARM branding too.
I know
so
you're
for
applying
on
it to
ARM,
everything.
yes. But yeah. So where we have already kind of talked about where to get started, but I'm more curious about like when we are at Open Sauce next week, because we're going to be at Open Sauce next week, and we have some developers walk up to this amazing glowing Ampere workstation, right? What's some of the stuff that we can talk to them about? What are some of the things? Because we can have this video playing, but I think that if you gave us some hard hitters here that we can
yeah. What resonates with developers?
Yeah, what resonates with your developer community, and how can we kind of talk about this machine?
I mean, so talking about events, some of the events that we've been at recently are things like Microsoft Build, which is a developer-focused event for Microsoft developers.
Oh, you were there.
I was just there.
Oh, you were?
Yeah.
We're going to be at Oracle Cloud World. We're actually running an ARM server track at FOSSE also next week.
Oh,
so
yeah,
you should send people from Open Sauce to Portland, Oregon to attend FOSSE from Thursday.
Is anyone from our team going to be at FOSSE, by the way, Michael? Or did we get anyone from ARM to go there?
I don't know. I sent it over to Robbie to see if he had anybody he could send.
Yeah, because definitely I feel like that's something we should try to be a part of.
It's one of those things. If we weren't doing Open Sauce, it's just so unfortunate that
they're the same days, right?
Yeah, they intersected with each other, and it's obviously we had already made the huge commitment for Open Sauce, but it's a little disappointing. Just bad luck.
Well, I'll pitch the ARM track at FOSSE afterwards if you want. But I would say, one of the things I think I said this earlier. One of the things that we've heard repeatedly from people is that they're really, really grateful to have real hardware in their lab or in their workstations to do CI/CD testing, porting work. that the availability of hardware that they could get and install in their rack is something that either by getting one of the Ampere servers and racking it up in a rack, or getting the workstation and just having that running on a desk. Like another example of you're all familiar with Alex Ellis of Actuated, I think. No?
Sounds familiar.
Yeah. So Alex is a longtime ARM advocate. Actuated is a platform that allows you to run GitHub builds basically on ARM hardware, bare metal instances, and it allows you to run that safely. So if you look at the GitHub documentation on GitHub runners, for example, it advises you not to do self-hosted runners on public repos because they're not secure. Alex provides a solution around that. So, and it's all open source, but he provides a hosted service for it. And the ability to do that on an ARM server is for him is super important. So the ability to have real hardware to do your work in your lab is something that people have been missing, and it's something we can provide now with the developer platform at a price point that's relatively affordable.
So is that something that somebody could just go to you and buy? Like, can they buy a server rack directly from Ampere?
Well, we have resellers. They can buy a server rack, and if anybody would like to contact me, I'll put you in contact. But one of our resellers is Phoenix, who's coincidentally based in the next town over from me. And you can buy the developer servers direct from AD-Link.
Yeah, I was actually exploring the website earlier today. Yeah, there's all sorts of different, I mean, you can go to the website at the top. There's on the navigation bar. In fact, I might as well almost just share this right now.
Yeah, I was going to say, you might as well post it.
Yeah, might as well here. So let me just share my screen. I was going to talk about one other thing, but I'll do two screen shares here. First, I'm going to share the Ampere website here. So if you go to the Ampere website, you'll see at the very top, there is where can I find it? Right here. Okay. So at the very top, you'll see the navigation bar. The navigation bar, of course, has company information and then products. And so from the product section, you can go to processors and you can see the different processors that they have here. You can go look at the product family brief, et cetera, contact sales. If you want to go buy 1 million of these things, I'd suggest, contacting them. And then you have, of course, platforms. And this is what we're kind of talking about here. So you have all the platforms here, these different server racks that you can get and plug right into your tower.
So as you all know, certainly as ARM folks, basically as a microprocessor creator, we tape out a processor, and that processor is built by TSMC in our case, but built by a silicon fab, and then we engage third parties, OEMs and ODMs, to create platforms around them. So that's everything that goes on your motherboard. Everything like fans, graphics cards, sound cards, interconnects, all that stuff. And so our resellers are all of the major OEMs that you had on there you are, the system partners that you see there. Among them, traditional enterprise vendors like Hewlett-Packard Enterprise. You also have, pretty well-known companies like Gigabyte, Supermicro, WeWin, Foxconn, Inspur. And as I said, that's Phoenix is the regional reseller or the global reseller. So that's the easiest place for you to get hardware. I think they have a 2 or 3 week lead time at this point.
Here's the
Ampere. I don't want to under or oversell them. I'm not sure if that's correct.
No, it's all right. You're in the business of chipsets, not distribution.
Yeah, but it is interesting. It's actually one of the things that, as somebody who came from the software world, I had to learn is we don't build these platforms. So we're not, when people ask, what software is supported on Ampere, that's not a question that we can really answer because, somebody could use a graphics card that we don't support. And that's their decision as a platform vendor and how they get a driver for that graphics card or for the BIOS that they choose. That's up to them.
Yeah.
But we do have reference platforms that we create the reference platform designed for and have those made on spec.
this was a big part of my role at my previous company, which was Lenaro. And so I was working in the 96 boards team where we had various specifications. It was the consumer edition extended, enterprise edition, IoT edition, and each one of these things came with a standard. And one of the big things was we brought in a bunch of SoC vendors. And so these people they made the chips, but then we would pair the chip makers with the manufacturer. And then we would pair the manufacturer chip maker with the distributor. So all of a sudden you have, Qualcomm teaming up with Arrow Electronics, and then Arrow Electronics sources some manufacturer. They put the chip on this thing, and then they make sure that all of the other components on this board works, and then they ship it. Right. And so it's very similar when you think about this just on a enterprise grade scale, right? When you're talking about these big cloud chipsets.
I will say, like, we've kind of caught a wave in the last 5 years compared to, I was reminded, so John Masters, another friend of ARM.
Yes, amazing guy.
John,
we need you on the show. John, if you're watching, come on.
So John recently reminded me that it was in Red Hat Summit 2013 that he did a bicycle powered server demonstration. I don't know if you remember this.
I saw it on LinkedIn.
Yeah, so he connected a dynamo up to, like, he had a stationary bike. He connected a dynamo up to the back wheel and charged a battery that was powering a Calzeda server, which kind of brought me back to, you think back to Calzeda. Calzeda had their first server design was, 2011 or something. So this is, we've been on this wave of getting ARM servers to mass adoption for 10, 12 years. And I feel like the hardware standards and some of the work that ARM did, that John did in Lenaro, actually in the Lenaro Enterprise Group, kind of driving some of those hardware standards for power management, for peripherals, has really enabled us to do what we're doing now. That we're seeing this, the mix of OCP and Lenaro driving that standardization in the industry has been really beneficial to the ARM server market, I think.
Very nice. Very nice. So I wanted to, before we lose track, speaking of waves, since we're on this wave right now, I did want to bring up this program that ARM has. And this is called the Works on ARM program. Now, of course, most of these providers, and sorry, I'm trying to find this window. Most of these providers feature the Ampere chipsets. So you have Equinix, which was, I believe, the founding member of this Works on ARM program. They are running Ampere chipsets. Google Cloud, Google Cloud. I'm not sure about the OSL, Azure, as you mentioned, Oracle, Tencent.
Yep.
So all of these providers have Ampere chipsets running in there. Now, the kicker about the Works on ARM program is that we have formed partnerships, some stronger than others, but for the most part, partnerships with all of these different providers. And there is a subsidized way of getting access to developer platforms on these different cloud providers, with these different cloud providers. So, for example, I think we've brought up Oracle quite a few times, but you can go to Oracle. Michael, you were saying that you get 4 cores as the part of the
4 cores, and I think like 16 gigs of RAM. It was a really nice offering.
That's their always free tier.
Always free. Yes. What was it? We had one of their developer evangelists on this show. It was like probably a year ago. And he was saying that, like, there's almost no way for you to run out of this tier. Essentially, it's always free. You can always have access to it. Some people were using it to, like, mine Bitcoin or something like that, where they have to kind of like add some sort of fair use policy in there.
Right. My kid's running it like 4 Minecraft servers on like 4 separate VMs.
I was going to say, it's like the 2 most common use cases are like running blogs or Minecraft servers.
Minecraft servers.
Always free tier. It's just a Java application, so you have your Minecraft server that you can connect to anywhere. Share with all your buddies. It's certainly something that my son has done.
Very cool. Yeah. So I just think that this is awesome, like in terms of making the decision, right? So, and this is what it comes down to is that you have a workload, okay, and you're exploring or entertaining the idea of possibly migrating this workload. And, by the way, there are many, many success stories out there of companies who have migrated their workloads over to ARM. And this is your opportunity to at least, try it out. Other than your time, there's no other cost associated with this. You can go see whether or not your workload is, I want to say ARM worthy, but for the most part, you're going to find performance and cost savings and performance improvements, to my knowledge, in most cases. So I'm going to stop sharing this now. Any last questions here? Because we are coming up on the top of the hour. I have some closing things that I wanted to go over with regards to OpenSauce, but are there any other last questions you have, Michael, that you have for Dave? Dave, any questions you have for us? Closing this out here. And then, of course, we'll give you your shameless
I did want
plug.
to share briefly the who's speaking and the track that we have for ARM servers next week at FOSSE.
Oh, please.
Yeah, we've got Eric Benner, who's an Oracle champion and ARM enthusiast. He's also an Ampere ambassador, who's going to be talking to us about deploying a cloud workload to ARM servers. We've got to think about it now. Sorry, brain freeze. I'll be on a panel with Eric, with Lance Albertson from OSU OSL, who's going to talk to us about managing ARM servers in production, in like a production rack. And then we're going to also have what's his name, the developer of the C compiler that Uber are using to do all of their Zig C++, Andrew Kelly. So for those who are unfamiliar, Zig C++ is Zig is a compiler suite. It has multiple front ends and back ends, and it's a compiler suite that advertises itself as a hermetic compiler, which means that everything in the binary is included, all of the runtime information that you need, any libraries that are required. And one of the things that's interesting to me is, like, this is something that Uber have used to do cross-compilation of everything from the ground up of their, they have their own custom Linux distribution that they use for all of their applications, plus all of the applications that are running on top. And so we're going to talk to Andrew about how and why he created this compiler suite for which cross-compiling is a tier 1 use case that he supports. So it's going to be a super interesting track. And yeah, we would love to see people there.
So FOSSE, we will make sure that the link to FOSSE is included. Are there still tickets available, or how would someone get access to this?
I believe there are.
Okay, so let's make sure that the link to FOSSE is included in the description. We'll get it in there.
2023.fosse.us.
2023.fosse.us. Yeah, we should have had that ready in a banner. So for everyone watching, sorry about that. It will be popping up here. Hopefully,
well, I just said it now. How could you? How could you have gotten?
And that's in
2023.
That's in Portland, Oregon. Not this weekend, but next weekend, the 15th and 16th, right?
Yeah, and the ARM track is on Thursday, the 13th in the afternoon.
Nice.
Yeah.
All right. Well, Dave, that's awesome.
Yeah.
Very excited. Very exciting stuff happening, around Ampere, the developer community that you guys have growing right now. I think that it's awesome. I want to give a personal, shout out to Aaron Williams, who I think is watching right now.
Yeah,
and
sure
also
be happy to hear it.
Yeah, and also Joe Speed. Those two gentlemen have just been amazing individuals in the ARM developer community. They've been participating in all of the things we do, including the office hours. Aaron actually came on to one of these shows with us one time and participated, and just thoroughly engaged with the developers in our Discord server. So that's just been a lot of fun having them around. So if you're watching, Aaron or Joe, thank you very much for being a part of the community. And now, Dave, thank you for now becoming the part of our community. And we look forward to also becoming a part of the Ampere developer community.
You are most welcome. And you're most welcome.
Welcome. Yeah, no, it's really been great. And thank you for coming in clutch here for joining us on this episode. It really has been a pleasure. So, unless there are any other things that we need to cover, I would like to close this out. I have a few small announcements to make around OpenSauce. Dave, if you'll just stick around for a second while we close this out, and then maybe we could talk in the green room afterwards.
Sure.
Okay. All right. So I'm going to make us big here while we kind of go over this. Actually, I don't even need to do that because I'm going to share my screen. So next week we will be, for those of you who are not at FOSSE, we will be at the Open Sauce event up in San Francisco. In fact, not only will all three of us be here, as in Gabriel, he's in person, Gabriel,
Yes,
myself, and Michael.
I'll be there.
Yeah, Michael will be there. We'll have two other ARM colleagues who will be joining us, and we will be having an ARM booth. So we have a nice big space. We have a really cool setup there. We will be showcasing 2 major demos, and we will be hosting 4, possibly more, but at least 4 live streams, Innovation Coffee special brew live streams on site from the booth. One of the demos that will be featured will include the Ampere 80 link workstation. So we'll have this with a nice demo running. We'll be bringing that up to San Francisco with us and showcasing it at the booth. Anyone who has Ampere questions can come ask us. We'll be ready and equipped to talk about this device in particular, as well as the demo that we're running. We have another surprise demo that we'll be showcasing as well. And then these live streams. Now, this is the cool part, is that as part of our sponsorship with Open Sauce, we will have 4 amazing content creators joining us on our special brew live streams. So I'm going to be able to talk about 3 of them right now. And we're still, we have a special one that will keep a surprise for you as the 4th guest. But the first guest that we will, I'll talk about here is Stephanie. Now, Stephanie has been a close friend of mine for a long time. She's an amazing individual. She has been on Innovation Coffee once before. I also hosted her on my Open Hours live stream back in the day when I was at Lenaro. She is just great. So you can actually go search for Stephanie on YouTube, but you can of course join us next week.
Also on the Discovery Channel.
On the Discovery Channel, yeah. For they're called Revengineers or Avengineers. Revengineers.
Oh,
I think it's Revengineers. A very cool show that they did with Mark Rober, right?
Yeah.
Yes. So there we go. We have Michael Reeves, who will also be joining us, another really cool content creator on YouTube, and Sean Hodgins. So we have these 3 individuals who will be joining us, and then a secret guest who we will keep a surprise for the day of. Yeah.
Yeah, it's going to be awesome. I will say that we are still going to have our normally scheduled Innovation Coffee next Thursday as well. Because we'll already be up in the Bay Area. We're just going to be filming from the ARM office with some ARM experts. So that one will be fun too. So don't skip out on that just to attend the weekend streams. Like, we will still have a great stream next Thursday.
Yeah, don't skip out on.
Sorry, I was going to ask, are those always at the same time?
These live streams are always at the same time. So we go live at 5 p.m. UTC every single Thursday. We do what we call special brew episodes. And so these are going to be special brew episodes. So if we go live at an event or something that's off of our regular time slot, we call them a special brew, and we'll be having 4. And so the idea of these particular 4 episodes is that since the event is 2 days long, it's on Saturday and Sunday, we're going to have an opening episode to kind of like talk about what we're excited about. We'll bring on one of these content creators to join us, talk about what they're excited about, maybe get some, fun questions about their particular, experience as a content creator being involved in this event, and just, being a content creator on YouTube. And then we'll have a closing on each day. So an opening on each day and a closing on each day, what we enjoyed throughout the event, what we look forward to, and what we enjoyed.
Yes.
Right. Okay. It took me a whole bunch of words to say something so easy. But yeah. Okay, cool. So that's the Open Sauce event next week. As Gabriel mentioned, we will be joining you as well for our regular scheduled Innovation Coffee next week from the ARM office in San Jose. And we hope to bring on some ARM experts from that office there, possibly showcase some demos on site. So yeah. Okay. Great. So for anyone who I'm pointing at the camera now, for everyone who enjoyed this broadcast, make sure you like and subscribe to the channel, like the video, subscribe to the channel. As Gabe just put up right here, we have the ARM developer program. Don't forget to go check out arm.com/developer program. If you are a developer, we'd love to have you as part of our network. Sign up there, become a member, join our Discord, discord.gg/ARM software dev. The Reddit right there, we have reddit.com/r/ARM software dev. We have our Twitter, ARM software dev as well. You can go check out the ARM software dev everywhere. It's our entire portfolio. Yeah. And don't forget.
I'm trying to guess which ones you're going to say next. Did I get them out of order?
And don't forget to go check out the Ampere community site as well. Let's see if Gabe can catch that one. Boom. All right.
No,
Gabe, you messed it up.
I'm totally
Specific,
anticipating you wrong.
Okay, so don't forget to go check out the Ampere community site. It's a great place where a lot of people are interacting around the around the Ampere workstations and cloud environments and all that good stuff. So make sure you go check that out as well. All right, so I think it's time to close this out. We hope you all enjoyed, and we look forward to seeing you in the next episode of Innovation Coffee. David, once again, Dave, thank you so much for joining us. We really appreciate your time, and hope you have a nice rest of your week.
You're welcome. Thank you for having me, Robert, Gabe, and Michael.
It was
good to see you again, Dave.
All right. Take care. See you next week on Innovation Coffee. Thank you.
Peace.